I'm here to talk to you a little bit about blockchain and a little bit about AI and how those things might intersect in the future. Usually I'm preaching to a relatively skeptical audience, but I know since you're here to learn about AI, that'll probably be less so today. Let me get into it straight away. So I think one of the things that's always inspired me is technology's ability to create a more fair, more equal, a better world for all of us, actually. It has this promise of creating an infinitely better place for us to live in and to solve problems and things in our everyday lives and super problems that might affect us and the planet in the future. And if there was ever a technology that was on track to do that kind of thing, probably AI could be that kind of space. But what I've kind of increasingly been seeing, and it's probably no stranger to most of us now, it's coming forward in recent media, is that may not actually be the way things panned out. You know, those early days of the internet where we thought about democratizing information and making things available to the everyday person that wasn't normally available to them, education, all those kinds of things. Actually, we started to see a trend with technology companies that's kind of not that good. And instead of kind of going down a path of sharply changing our future with technology for the better and for the masses, we're actually starting to see technology companies and their position in our world going in the wrong direction, and that information that those companies are kind of gathering and using in processes and systems having unintended consequences or outcomes that either were by design or through ill thought or through pure misunderstanding of how this thing might go in the future. And I think that what we started to see is actually a trend away from equality from technology. You know, we're creating these super companies that have a lot of power in society, creating an environment where you know, everyday people are getting shut out of value chains, even though they're huge participants in those value chains. Further centralization of wealth in economies than has ever happened before in society. And so this promise of technology to give us this world in a better place and a fairer place for everybody to exist in hasn't really panned out. And if we keep going down the path that we're going down now, it's probably going to get worse. And actually, AI could be one of the things that goes either way. It could help and make the world a better place, or it could actually make it a much worse place than exists for humans. But hopefully I think there's a revolution on the way, and I'm going to talk a little bit about that revolution today, and it's kind of a more human thing than a technology thing, but hopefully there's some technology here that can help enable it. And I think if we do this right, some of the giants that exist today, hopefully they won't exist in the future. We'll have a different kind of model of participation between technology and humans that should see a fairer world for us all, should allow us to solve some of these problems without eroding some of our rights, which is kind of the thing that's happening today. So to get into that, I'm going to talk a little bit about blockchain first, and then a little bit about what AI and blockchain could do together to change this path that we might be on. First point, Bitcoin is not blockchain. Really, really important. I get asked this a lot, and I get questions a lot about blockchain, and the first questions that come out about Bitcoins and what coin should I invest in, and why has the value gone down so much, and blah, 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 blah. I'm not going to tell you what coins to invest in today, but the thing that Bitcoin proved is that we could solve a problem that had been difficult to solve before. In fact, had never been solved before. And that was, how do we create a system where digital assets could be traded, and we could do that in a trusted way, and we could do that without a middleman. This problem is called the double spending problem. So in the physical world, we can kind of pass an asset between us, and that's cool. We know that the thing I'm giving you is a real thing, and you can give me something in return for that, and that's a real thing. And in the digital world, we have the ability, the internet's created the ability to create information, and information sent all over the world, and that's kind of the internet's purpose, and that's really cool for document sharing and cat memes and all the things that we love about the internet. And so we've got this great information superhighway. But what actually happens is when we kind of send stuff across the world and all around the world, we're sending copies of those things. Now, that's cool, except if that thing has value. If I can copy it easily, then it loses its value. So how can we create a system where I can send digital representations of assets across the world to other people? They can trust that what they're getting is the real thing and that it's not a copy, and we're not eroding value in the system. That's the thing Bitcoin did first, created this system of trust for digital assets. We'll get to why that's important in the future. So what's in a blockchain? Well, there's three kind of main bits to it. There's lots of stuff that goes on beneath this and above this and in the applications, but main things are we've got a client, which could be a wallet or an application, something like that, that kind of sends transactions and receives transactions into the network. We've got nodes that store a copy of the blockchain's history and keep that and replicate it across the world. And then we've got miners who are mining transactions. Those are kind of three bits of a blockchain. There's different variations of this, but in principle, they all have these three elements to them. So what is this mining? And this is quite an important point. The most common type of mining out there at the moment is called proof of work. And it's a system that Bitcoin uses, it's a system that Ethereum currently uses. It's not the only system. And so there are other systems out there that provide the same outcomes, but do it in a different way. More energy efficient systems, faster systems. But we'll go through proof of work because it's a common one that's out there and it illustrates the point. So how does it work? We get a bunch of messages sent into the network. Message could be, I'm going to send you a Bitcoin. Once there's a bunch of those messages in Bitcoin's blockchain, around 10 minutes, so all the messages get bundled up into this block, and attached to that block is a special maths problem, and computers all over the world race to solve that problem. And the problem's kind of like unlocking a padlock. So there's a padlock here, and there's a key that unlocks it, and people just throw keys at the padlock until the right one sticks. And that process is what generates the randomness in blockchain transaction authentication, and it helps create the ability for blockchains to have some interesting properties down the track. So once someone finds this key, just by throwing millions and millions of keys at this lock, they broadcast to the network and say, I found the key. Everyone's like, oh, that was the key, cool. And that block gets added to the chain. Now, there's a bunch of rules that you have to follow in order to get transactions added to the block and for the block to be confirmed. And those rules are authenticated by the protocol. And once that happens, the block gets added to the chain, and it contains a reference to the previous blocks that existed before it. And so over time, not much time actually, to undo something back here, you have to undo everything that's happened between here and there. And that costs a lot of energy. So I remember before I was throwing keys at the lock, the process that does that is typically a graphics card. And the work that it's doing is using electricity and computing time to unlock this lock. So what that does is it means that we can prove that the only effective way to participate in this process is to have a real machine that burns real electricity to solve that problem. There's not like a mathematical trick that you can do to try and outpace the rest of the world. You can't create lots of fake identities and try and force your opinion on this world. You have to have a real machine doing work, and that work is unlocking this lock. So this is what proof of work is. It's proof that a real machine exists and it really did this work. Why is that important? Well, it's important because it means that this network is censorship resistant for a start off. Anyone can join. You don't have to get a license to run Bitcoin. You don't have to ask anyone's permission to do it. There's no sea of Bitcoin that tells you what the rules are. Anyone can join this network. Why is that important? Well, it's decentralized. And that's the crux of what we'll get to today. Some other benefits. Well, we talked briefly about decentralization. I'll go some more into that later. But it's this thing that isn't controlled by a single entity. Anyone can participate in this network. Anyone who wants to run a Bitcoin node can. And similar for all public blockchains. It's highly resilient. There's lots and lots and lots of computers and lots of people and lots of locations around the world connected to lots and lots of internet connections, all running this protocol. So it's quite hard to attack from a single point of view. It's quite trustworthy. The process that goes through to get a transaction in the block means that someone can't go and change it in the future if they feel like they want to. It's very hard to do that, and it's akin to saying, all these information going into this block is like taking a chicken and making chicken nuggets out of it. In order to undo transactions would be like taking those chicken nuggets and remaking a chicken. It's really, really, really hard. So you can trust once information's in there that it's not going to be changed. And it's highly secure. So it's built on cryptography from the outset. So the systems that are involved with running this stuff, the core protocols that are involved with it are all powered by cryptography. So they're very secure. So what if you took that kind of technology and those kinds of benefits and you did something else with them? This is where blockchains went to next. They took those properties of decentralization, the high level of resilience, the trustworthiness of the transactions, the immutability of the data, the resilience of the network, and they applied those principles to applications. So now we can build apps that have the same principles that currency had in Bitcoin, which means now you've got, instead of a global ledger of values recorded, you've got a distributed global computer that can run applications that are also decentralized. And that's the kind of cool power that Ethereum brought along first. They made the same properties available to applications that we could do with transactions. Ethereum was the first one. Recently we launched Plug, built here in New Zealand and with our partners up in the UK. Totally new framework for building blockchains, built from the ground up. It's not a fork or a rehash of someone else's technology. So really excited about the possibilities for new types of applications built on these frameworks for taking those properties and building them to apps. So what is a smart contract? This is what these apps are called. Typically you'll hear this term in the industry. So it's an autonomous piece of code that runs inside one of these blockchains. Once you deploy it, you program it to do a thing, it will always reliably do that thing. And this is a really important point. So if we want to create trust amongst people who don't know each other, without these intermediaries sitting in the middle of these value chains, we have to trust the code's always going to do what it's programmed to do. And that's what these smart contracts do. They're the foundation for decentralized applications. They can take a process like, I'll put some value here and hold it for a period of time, and then I'll release it on these conditions. And you can trust that if you put that value there and those conditions are met, then it will be released. And so now you can take any process that has these kinds of attributes to it and build a decentralized application. That code lives in the ledger, and actually no one can change that unless they get your express permission to do so. And they have to tell you because it requires deploying a new contract. So when you deploy that new contract at a new address, it's a new set of code. And so you can't kind of do any tricky behind the scenes stuff. Of course, if you write bad code or code with tricks in it, those types of things can be performed, but this is all open source. Everyone can see what's written inside these contracts, and therefore they can validate that what you're telling them is actually true in the code. So what does that give us? So we're in a situation now, we've got these cool applications that can be run in these decentralized computing environments. What does that actually give us as a society? Well, it gives us this thing, trust. It gives us the ability to create new economic models, to create new systems of information working together, to create new types of applications which are directly peer-to-peer. And I don't mean peer-to-peer in the sense of Airbnb, which is peer to Airbnb to peer. This is genuine peer-to-peer between individuals or entities in the real world. And we can trust that those things that are programmed into those applications are really going to happen. And so I don't have to trust an institution, I don't have to trust a middleman, I don't have to trust a corporation. And that's really, really, really cool. But why? Why would I decentralize? Why is that important? Well, companies don't always stay the same. You know, we all believed once upon a time that Facebook was a great company that wasn't going to steal our data and try and change elections. You know, that was something that we all believed deep inside of ourselves. But unfortunately, you know, unintended consequences or malicious activities or the desire to make Farm Bill even more popular led to this outcome. So companies change. Well, the other thing is intermediaries, they take more money, more value than they give. You know, huge amounts of value going up in these value chains, and whole industries being swallowed by single companies. That's never happened in history before. It's not a good thing, I don't think, for us or for society or for the everyday person, because at the end of the day, if centralization wins, then most of us lose. That's just maths. And you can't escape that fact. But I think one of the most important things is kind of becoming very evident in the last couple of weeks. Bit of a joke, but not so much. Because in the future, when AI really comes into its own, do you want a company owning the virtual you? Because right now that's what happens. So you go and download all the information that Facebook has about you and Google has about you, and they've constructed the virtual you. And the virtual you is actually being used in real-world processes. And the information about the virtual you is being used to influence real-world processes. Now, whether you believe it or not, this Cambridge Analytica thing, what has actually happened in that value chain is we took this virtual you, we put it through a machine that told us how to target voters who voted in an election in a specific way, and one of the most immediate results of that election was that government took away some of our fundamental rights on the internet. So we kind of sit here and say, well, this stuff is fanciful and it's in the future and it might not never happen. It's actually happening today. And we could say, well, we're in these democratic societies and we make the choices and we're the people who decide at the end of the day. But if your thinking's influenced by one of these very powerful machines, and we've probably learned a lot about these powerful machines and powerful software programs over the last few talks over the last day or so, if those things are even half true, what those vendors promised, this is a very scary prospect because we're actually changing the way democracy works. And that gets to a point that gets out of our control, and that's really, really scary. So, how does this blockchain thing work? You know, what are we doing about this? How can we make a difference? How can we go down a different path? How can we take the best of what AI has to offer and give us some control over that as human beings? What we're trying to do in Centrality is to get mass adoption of this blockchain stuff. And the main purpose of that is to give you control back of your virtual self, put you in a position where you own your own information. It's locked under your own private key. It's not owned by a company, and you can share that in cool new ways that mean you don't have to give all of that information away to participate in a process. And in fact, to go a step further, you could also participate in the economy of those applications in a meaningful way. So one of the things that's important to the way that we've been approaching this is blockchain adoption is really low, particularly in mass market use cases. You know, fintech, it's getting some steam on. You know, the kind of speculative currency trading world's kind of gone and running and possibly dying at the moment. Hopefully it does at some point. And consumers, everyday people kind of interacting with these processes, it needs to be natural, it needs to feel like a Facebook experience. They don't have to think about blockchain necessarily, but they need to understand the benefits it provides them and know enough to protect themselves to, you know, engage in good economies and good applications. So we're building a platform to join the dots between different applications to help them scale and grow together so they don't have to go one-on-one against the Facebooks and the Googles and Alibabas, that they can cooperate. Where the user's at the center of that ecosystem, they can carry their information between applications, they can carry the value between applications, they can transact seamlessly and frictionlessly in this environment. And how are we doing that? Well, we're creating this marketplace experience. You know, we're building the technology components. Ahmed here down the front is one of our developers who's working hard at this stuff, right from that blockchain infrastructure up to be consumer friendly, to take care of the problems around managing your private keys and recovering things and all that kind of stuff. The wallets, the rails that need to make payments work, the big data frameworks and APIs to interact with blockchain environments, the sensor networks that might contribute to applications, all of the stuff around the blockchain to make it easy for developers to develop in this space. Incubators to help foster growth in this environment, to provide skills and expertise, and to funding to these organizations and this marketplace. So that's our little bit, is trying to get consumer mass adoption happening in this blockchain space with decentralized applications and powering up this world. So how does this AI blockchain thing work? How do the two intersect in my mind? Some of this stuff is kind of early stage, and so I think you take, you know, these as indicators of where things could go rather than practical things you could do right now. just like a lot of AI actually. We're building up these infrastructure levels and frameworks and models and stuff in early use cases to prove out what a genuine AI could be in the future. Blockchain's kind of in that space. But in this future, we've probably got a couple of things happening. First of all, the way that we transact with each other is probably going to be more driven by machines. We've got a lot of human interaction and transactions today, but if you think about your virtual assistants or IoT devices, these kinds of things will start making transactional decisions for us. And the current system in which transactions are made is very full of friction. We have contracts to sign and accounts to sign up for and negotiations about things to happen. If those things are happening in the future with machines, it needs to be a much more frictionless system to do so. So how do you create that system? Well, you can tokenize those assets and program those assets, make programmable money, and allow machines to interact with that thing with a set of rules that you can trust that will always behave the same way that you program to do. And so you can step back from this world of managing this thing yourself and trust that the machines are going to be able to do this in an effective way, in a low-cost way, without a big intermediary sitting in the middle that you trust. And that creates this shift from this internet of information to this internet of value, where we can transact with machines and machines can transact with machines and create this new type of economy that we're a part of, that we're an owner in. And some examples of what that might look like in the future, we could take things like creativity and make them money. This is Grammatic, he's a producer. We're working with a business called Singular DTV to create the underlying technology to help creative people tokenize themselves, engage directly with their fans without record labels or production companies being involved in controlling that creativity, without taking an asynchronous part of the benefit of that equation. Their fans can participate in that economy directly. If Grammatic does well, they do well, they support each other, and that becomes a currency, this creativity. Let's take identity as another example. Single source, a platform that we've developed to create your own identity and give ownership back to you. But let that be involved in processes like banking and money laundering checking and credit scoring and attestation of certifications and all the things that go around your identity. Give that power back to you for the information, and then you can transact with that information inside of systems and get value from it. And as this grows, then your value in the system grows. And then in the future, maybe, let's look forward a little bit further and see how can some of the technologies or principles and blockchains help us create a better future with AI? How can we kind of create an acceleration of this technology, but in a more trustful framework? And there's three things I've kind of pulled out as ideas maybe that we could look at. First thing is AIs need data. So we want to give AI data and information to train them, to be able to learn, to be able to create better models, those kinds of things. But we want to make sure that people feel comfortable doing that. So how can we provide AI information without centralizing all the information, which is what's happening now, right? So can we create new frameworks for sharing information and also participation in the economic value of that information, so that enables people to share more information freely and trust the information going into these systems? I think that's one area that blockchain and AI could work together on, create new incentive models and create new trust models for sharing information. Second thing, let's increase artificial trust. So again, we've got this system where machines are talking to machines, they're negotiating with each other, they're transacting with each other, they're doing this on our behalf. So how does a machine or an AI get a CV? How do we know that it's going to perform things in the way that you said that it was going to perform things as an organization who created that thing? Can we give trust to these machines in a way that means that we don't have to rely on a third party's word today or in the future? So creating trust frameworks for these machines using blockchains. And third one, which probably might be a little bit further out there, is to reduce this kind of catastrophic risk chance. Can we code the logic from these machines into a DAO type construct to give the machines a confined workspace? Could we take an AI and give it the same properties that exists in a decentralized app in a blockchain? that its working space is constrained, that the things that it's programmed to do, you can rely on them doing all the time without changing. And I guess this depends a little bit on how sophisticated AIs get in the future. But at least in this medium term, I think this is an achievable goal for us. So I think if we think about the future and we look at our virtual selves being important in this future and what the information that those machines or those AIs are using with that virtual self, this intersection of blockchain and decentralization and AI, they could work really well together to make sure that we go on a better path than we're going on now, that technology can work for us, that we can really be part of the economic value of these systems, and that we can look forward to a future where technology does meet that promise of making the world an infinitely better place for us all to live in. So thanks for your time, guys. It's been great.